Okay. Now, order of a tensor. Okay. I have a tensor, zero order. The zero order tensor, by definition, is scalar. Okay? The first order tensor is called a vector. Okay? Now, second order tensor, you see, in general, in the linear algebra, you play with second order tensor. Okay? This is scale, this is a vector. This I call second order tensor. And then you have nth order tensor. Okay? Now, for instance, the previous video we saw the definition of Gij is equal AI dot AJ. You see, only dummy indices. So, this is a zero order tensor, this is a scalar. Okay? Now, first order tensor, was I'll write V as a linear combination of V1, A1 plus V2, A2 plus V3, A3. Now I can express this as VI, AI. Attention now. That's is a little confused. You see, this is a first order tensor. This is only dummy, but the first order, you see the number of free index. So, the number of free index, we call this as a vector, okay? This here, attention now, is component, okay? So, let's call an S here, components. You see, if I expand this, I have this. So, if you define a vector as first order tensor, one free index, look, this is one free index. The scalar with zero, we have zero free index. See, you see the name, you just look on the components. You see, look, this is a first order tensor. You don't look the tensor here, the vector. You look only for the components. This is a convention, okay? Now, second order tensor, okay? I'll write first A is equal A11, A1, A1 plus A12, A1, A2 plus A13, A1, A3 plus A, now you see, one here, and one here. Now it's 2. 2, 1, A2, A1 plus A2, 2, A2, A2, plus A2, 3, A2, A3, plus, now see, 1, 1, 1. Now, 2, 2, and 2. Now let's write, begin with 3. 3, 1, A3, A1, plus A, 3, 2, A3, A2, plus A, 3, 3, A3, A3. You see, we have here 9 components. 9 components. Okay? 9 components. See, now, see, then I can write all this here. You see, look how it's simple. You just write A, Ij, Ai, Aj. You see, this over here exactly, if you expand here, then you first expand on I, then expand on J. You see, you're going to get all these 9 terms over here. Now, the name second order tensor, you just look for the components. You see, 2, 3 indices. So this implies that is second order tensor. Second order tensor. You see, a third order, I'll put a third order tensor, then you, let's put it here, third order. Now, I have, for instance, T, see? Now, this will be A, put there, T, I, J, K, for instance. Then you have AI, AJ, and AK. Again, you see, 3 indices. Then you call a third order tensor, and so on. You see, as I said before, when you say this is a tensor, actually, that's a very important property. I'll show easily, give an example of a vector. A vector. See? Look. I will repeat this, you see, along all the classes, all the lectures, okay? Then you're gonna get used to this. Look at that, you see, I have a vector, okay, down here, okay. First order tensor. Example. For instance, this is a vector. Then I have, for instance, V is equal VI AI. Now, attention now. This is dummy, but you have the component VI, you see, I have 1, 3 index. Now, since V, attention now, V, not VI, since V is invariant, so I can write here, for instance, the same vector V, I put AJ AJ. No problem. You see? I just look at here and look at here. This is one free index. So that's why this is called the first order tensor. Don't look at the tensor. You put the name, you look at the components. That's quite confusing, you see? So get used to this. The same, for instance, I have a vector, the position vector R, okay? I can write, for instance, let's put X. No, I don't call X. I call C, I, A, I. You see? Now, it's a, okay, I'll talk this later to you in another video. I'll just write down like R, if you remember, dr is equal d c I a I. See previous video, okay? I wrote this. This is a dr. Now, what is this? This is a vector. Why? Because one free index. You see? Now, dr